Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve next question. Question number 10, 2014 NEET paper. Students, let us solve the next question, question number 10. This says that the ratio of accelerations for a solid sphere, mass m, radius r, rolling down an inclined plane with an angle theta without slipping and slipping down the incline without rolling, without slipping and without rolling. So one is rolling and another is sliding. So to find the acceleration without slipping means rolling, divided by acceleration due to without rolling, that is sliding. This ratio to find. The situation is like this. There is a sphere which is released at the top here with initial velocity 0, angle theta, and the acceleration you have to find. What is the acceleration? In case of rolling, the acceleration is found to be acceleration in case of rolling g sine theta divided by 1 plus k square over r square. This is the acceleration. So how this is done, that we'll discuss later, but this is the case. And in case of sliding, the acceleration is g sine theta. So if I divide these two equations, a rolling by a sliding, it becomes g sine theta will cancel out, it becomes 1 upon 1 over a square. If I solve these two, if I put these values, it is 1 divided by 1 plus k square by r square. For a sphere, about this axis, that moment of inertia is 2 over 5, solid sphere, obviously 2 by 5 mr square, and that equals to mk square. M cancels out, k square over r square is 2 by 5. So from here, I substitute this value here and we'll get the result. What is that? A rolling divided by a sliding equals to 1 divided by 1 plus 2 by 5. If I put this 5 plus to 7, 5 goes off, so it's 5 over 7. A rolling by a sliding is 5 over 7. So 5 over 7 is the answer to this question. Without slipping, no slipping, only rolling, slipping down the incline without rolling, only slips down. So this is the case, 5 over 7. So this is the answer to this question, 5 to 7. But let me tell you how you got this expression g sine theta over this. You will get in your textbook. Otherwise also we'll discuss how this is done. If I talk about an object in an inclined plane, then an object which is just released outside, suppose vertically, here the acceleration is g. I'm not taking into consideration the negative g, only g. This is the path of the object, and in this path the direction of the displacement, the acceleration is g. If this angle is theta, the acceleration will be acting downward and the object is actually moving in this direction. So here and here there is a basic difference, that displacement is here in this distance in this direction, and displacement here is in this direction. Here acceleration in the direction of displacement is g, but here acceleration in the direction of displacement is not known, and that we have to find. We cannot take g over this because this is not the direction, this is not the component. We have to take the component of acceleration in the direction of displacement. If this is theta, this angle will also be theta. So this will become g cos theta, and this will become g sin theta. This component is g sin theta. Now you can say that this is the acceleration in the direction of displacement, but this is the case only in sliding, because the body will not rotate, only skids down. So in case of skidding, only this one is there, g sin theta. So then in this case we have taken g sin theta. If this is this plane is this plane becomes vertical, then this plane becomes vertical. This is the inclined plane, it goes on like that, like that, like that. This becomes vertical. Then theta is 90. If I put theta is 90 over here, then it becomes z. Okay, this inclined plane is made like that, then theta becomes 90 and cos sorry, I wear g sin theta, that g sin 90, sin 90 is 1, so only g will act. That is this case. Now if a body rolls apart from sliding, it is rolling actually. In case of rolling, we have got two types of motion taking place: rotation and translation motion. In case of rotation and translation, we have to, if I want to derive the expression, I may derive the expression like this, that I'll first take the energy conservation and find the V. Okay, I'll find the energy conservation. Suppose from here to here it covers the displacement S, this height is h. I'll write the energy conservation half of mv square plus half of I omega square, the total kinetic energy that I'm getting here is because of this potential energy mgh. This is half mv square plus 2 by 5 mr square, and this 2 is there, and this omega square is mgh. Only I have done put the value of I, which is 2 over 5 mr square, that is the moment of inertia, cancelling this. This is half mv square plus this is also 1 by 5 mv square, because v is omega r, so this half v square is mgh. From here I cancel this. So solving this, you will get the value of v here. You will get the value of v. But in general expression, from here I will just switch out half mv square plus half I is mk square, omega square is mgh. M will cancel out. So omega square is v square over r square, because v equals to omega r. So omega square is v square over r square. So this is half v square plus half k square into v square over r square equals to gh. If I take common v square by 2, this becomes 1 plus k square over r square. This is equal to gh. From here v equals to 2gh divided by 1 plus k square over r square under root. This is the formula for v. And if you want to find the formula for a, then v square, in this direction the acceleration was there, so v square is u square plus 2as, and I want a, so it is v square minus u square divided by 2s. This is 0 released. V square is this one, square of this, so square of this is 2gh divided by 1 plus k square over r square. The root goes, divide by 2 into s, this 2 will go, s is what? This is the inclined plane, this is your s, this is your theta, this is your h. I can write h, this is s, this is theta, so this is s cos theta, this is s sin theta. So I'll write s sin theta in place of h. H is s sin theta. This is s, this is theta, so this height will be s sin theta divided by 1 plus k square over r square into s. This s will cancel out, then that what is left is g sin theta over 1 plus k square over r square. This is how you get the expression for the expression of acceleration that I've directly used. This you can get. Otherwise, you can go for the force equation and torque equation, and then also from there you can find the value of acceleration. Anyway, the answer to this question is already we have got. The answer to this question is 5/7 here. So that was the answer, and is question option number 1. Okay, thank you.